and welcome my dear friends. My name is Kundan Kumar Singh and today I am going to deliver a beautiful lecture on mathematics dealing with the topic operation on whole number. That is operation on whole number. So in today's class we are going to study the second operation, that is subtraction. This is the second operation we are going to study in today's class, because the first one, that is addition, we have already studied in the previous video. If you haven't seen that video, the link will be provided in the description. You can go and watch that video first, and after that you can dive into this topic. So in order to perform subtraction on whole number, you have to deal with certain properties related to subtraction. So what are those properties? There are altogether 5 number of properties regarding subtraction. So we will study one by one in detail. So without wasting time, let's get into the actual topic, that is property of subtraction. And this property, we are telling that A and B are two whole numbers. So this A and B can be any number out of this range. For suppose, how can we pick up the value for A? For suppose I take the value for A as 5, okay? Then what will be B? Will it be 6? No. You have to check this condition. This condition, you have to check it. So here it is telling A greater than B. That means we have written A equal to 5. Then what will be B? B will be obviously less than 5. So it can be either 4, 3, 2, 1, anything. Okay. So I am taking 4. So these are two whole numbers. Okay. A and B are two whole numbers. Once we have decided, then we are responsible for performing this operation, that is A minus B. So the result what we will obtain over here is 5 minus 4. A is nothing but 5, B is 4. So 5 minus 4 is nothing but 1. So you have to check whether this 1 is falling in this range or not. Yes, this 1 is falling in this range. That means 1 is also a whole number. If 1 is a whole number, then we can conclude that this A minus B is also a whole number. I hope you are clear. A minus B is also a whole number. Why? Because we got the result as 1 and this 1 was lying within this range. Within this range. What is that range? 0 to infinite. Within this range, this 1 is lying. That's why we concluded that this A minus B is a whole number. But what if we think in reverse? You may say that, sir, why I will do A minus B? I can do B minus A as well. So let's check that one. For suppose B minus A we are going to perform over here. That is, B value is 4 and A value is 5. So 4 minus 5, it will yield the result as minus 1. Okay. Now you tell me, this minus 1 is lying within this range? No. Where it is there? Here you will not find minus 1 within this range. That's why, because all these numbers are positive numbers. Why? Because there is a minus symbol. So this minus symbol and this is a minus 1. So minus 1 does not lie within this range. That's why we conclude that this B minus A is not a whole number. Okay. So B minus A is not a whole number. That's why we conclude a statement that A minus B we can perform, but B minus A is not possible in case of property 1. I hope you are satisfied with this property 1. Now I will be moving to property 2 for subtraction. So I am erasing all this. Alright. We are now looking at property 2 in case of subtraction. What is that? Commutative property is not possible here. What does this mean? What does this statement signify? I hope you are not understood. So let's understand over here. For suppose A and B are two whole number, are two whole number. Okay, this A and B are two whole numbers. Then in the commutative property we know that A minus B must be equal to B minus A. Okay, in the case of, in order to satisfy commutative property, it must be equal. This expression, what is that? A minus B must be equal to B minus A. Then we can say that these two expressions are equal, and we can conclude that this will be a commutative property. But in this case, in case of subtraction, while performing subtraction on whole numbers, you cannot write A minus B equal to B minus A. You cannot write. That means whatever the result you are going to produce by performing this operation A minus B will not be equal to B minus A. That means if you are not able to make them equal, then we can say we are not able to perform commutative property in case of subtraction. I hope you are clear. In simple words, you just remembered, in case of subtraction, while performing subtraction on whole number, you can never perform commutative property. Commutative property is not applicable in case of subtraction on whole number. I hope you are clear. Now I am moving for property 3. I am erasing this. Listen. Here, in case of associative property for subtraction, here you cannot perform this expression equal to this expression. This is what I mean in case of property 3 for subtraction. What is that? Associative property is not applicable here. Associative property is not possible here. That means when you are performing subtraction operation, their associative property is not possible. So how not possible? That means this statement we have to verify. This statement we have to verify. What is that? A minus B minus C. When we are performing this expression, it must not be equal to. This is the symbol for not equal to. Okay, not equal to A minus B minus C. So let's take example over here. For suppose I am taking the value of A as 6, B as 5 and C as 4. Okay, these are three whole numbers. Okay, according to this statement, here A equal to 6, B equal to 5 and C equal to 4. These are three whole numbers. When we perform this operation, we just need to verify they must not be equal. If they are not equal, then we can conclude that it is not satisfying associative property. So let's do over here. A minus B minus C. First of all, we will do this side. A minus B. A is nothing but 6 minus 5 minus 4. So within the bracket, first of all, you have to solve it. What is that? 6 minus 5, it will yield the result as 1 minus 4. 1 minus 4 is nothing but minus 3. Okay. Now in the second time, you have to do A minus B minus C. Okay. Here A equal to 6, B equal to 5, C equal to 4. 6 minus, within the bracket, first of all, you have to solve it. 5 minus 4, it is 1. Okay. So 6 minus 1 is nothing but 5. So here you can clearly see that when I am performing A minus B minus C, first of all A minus B was within the bracket, second time B minus C was within the bracket. When I am performing these expressions with the help of these values, I am getting different results. What is that? Here I am getting minus 3 and here I am getting plus 5. So both the results are different. They are not equal. This expression and this expression here, they are not equal. If they are not equal, that means we can proudly say that it is not satisfying associative property. So you remember in simple word is that in case of subtraction, while performing subtraction on whole number, you cannot perform associative property. I hope you are clear. I am raising this. Alright, this is property 4 in case of subtraction on whole number. What is that? If A is a whole number other than 0. Okay, here A equal to 5 I have considered. Excluding 0, we can take any other whole number. So that means we are going to exclude this 0 and we can assume any one of this number as a whole number. So here I have considered A equal to 5. So 5 is the whole number over here. Now we are going to see then A minus 0 equal to A. Okay. So we have to see whether this expression is satisfied or not. So here we will first of all write this expression over here. What is that? A minus 0. Okay. So A is nothing but 5. 5 minus 0, it will yield the result as 5. That means A minus 0 also we are getting as A. This 5 is nothing but A. So we can say that A minus 0, when we are performing this operation A minus 0, the left hand side value, what is that? A minus 0. I have written A minus 0 and I have replaced this A with the value 5. 5 minus 0, it will yield the result as 5. So this 5 is nothing but A. So once again I have written A. So this A is equal to A minus 0. That means we are satisfying this condition. Okay. But in reverse, when we try to do, what is that? 0 minus A. 0 minus A. Let us do it then. 0 minus A. 0 minus A is nothing but 5. So 0 minus 5 is nothing but minus 5. So can you say this minus 5 lie within this range, that is 0 to infinite? This is a negative number. This negative number can never lie within the range of positive numbers. These are positive numbers. So within this range, this minus 5 is not lying. That's why this operation 0 minus A is undefined. This is called as undefined. This is called as undefined or not defined. That means whenever you are taking any value, then you can, other than 0, whenever you are taking value other than 0 as a whole number and you want to perform subtraction, at that time you can do that A minus 0. A can be any value other than 0. Okay, A can be any value. You can take, you can assume A as any value other than 0. So after assuming, you can perform this operation, it will always satisfy this condition. But when you will try to do this condition, you will get the result as undefined. Why? Because whatever the result you are getting, that will not lie within this range. But in this case, the result we got 5 plus 5. This 5 is lying within this range. That means this expression you can perform. But when you try to perform the reverse of this, you cannot do in case of subtraction on whole number. I hope you are clear about this property. Now I am going for property 5. I am erasing this. Alright, now we are looking property 5 in case of subtraction on whole number. What is that property? Here, if A, B, C are 3 whole number, these are A, B, C. A, B, C is nothing but this is a variable, and this variable, it is a variable, A, B, C, D. These are called as variable, and these variables are used to hold whole numbers in this chapter. Okay? So here A, B, C are 3 whole numbers such that A minus B equal to C. So first of all we will look at this expression. What is that? A minus B equal to C. We have to prove that A minus B equal to C. So let's do it over here. A is nothing but, I have pre-assumed the values for A, B and C. What is that? A I have taken as 6 and B I have taken 2. For C I have taken as 4. So I will perform this expression first of all. What is that? A minus B. A is nothing but 6. 6 minus B. B means 2. So 6 minus 2 is nothing but 4. Okay. So here C I am getting as 4. Here also C equal to 4. That means we are satisfying this condition. We are satisfying this condition. Yeah. We are satisfying. When we are doing A minus B, we are getting the result as 4. Here C equal to 4. Here also C equal to 4. That means this condition is valid in this case. Now in reverse also we have to prove that this B plus C equal to A. So let's do it over here. What is that? B plus C equal to A. So B is nothing but here B. B we are taking as 2 plus C we have to take as 4. So 2 plus 4 is nothing but 6. Yeah, 6. So this 6 is nothing but A. So A equal to 6. Look over here. A equal to 6. That means we are able to verify this statement also. So whenever you are performing this property 5, you have to remember that A, B, C are 3 whole numbers. It will be a whole numbers. It is not like that you will take any numbers beyond this range 0 to infinity. You have to always pick up the value for the variables A, B, C in such a way that when you perform A minus B, you will get the result as C. So in vice versa, you will see B plus C equal to A. So these two conditions must satisfy, then only you can choose the value for A, B and C. I hope you are clear with all these rules. Now I am concluding my lecture over here. In the next class, we are going to see the third operation on whole number. What is that? Multiplication operation. But now, if you find any difficulty regarding these properties, you can comment down below in the comment section. I will definitely answer all your doubts and queries. Thank you and have a nice day.